The fusion fuel cycle is a vital system in all fusion power plants. It is a pathway of safely removing, processing, and re-injecting fuel to the plasma, enabling recycling of the fusion fuel. Within the deuterium-tritium (DT) fusion power plant, a mixture of hydrogen isotopes, D and T, are fused in the plasma to release energy. Deuterium is relatively abundant, while tritium is very rare in nature and is a valuable asset. It is also a weak beta emitter with a half-life of 12.3 years, and, like hydrogen, it has general handling challenges. In this video, we discuss 4 key areas of a fuel cycle, which are fuel recirculation, breeder extraction and purification, tritium recovery, and import and export.
The first key area is fuel recirculation, which is responsible for providing vacuum conditions in the plasma chamber, processing the plasma exhaust, and sending unspent fuel back into the plasma. As well as fuel, the exhaust also contains a mixture of spent helium and intrinsic and seeded impurities such as argon and xenon, which are used to manage plasma heat loads. These exhaust gases are removed from the plasma chamber using a series of specialist vacuum pumps into downstream processing systems. These systems, such as membranes, catalysts, and adsorption technologies, are used to separate the unspent fuel and seeded impurities from the exhaust. The fuel's composition is adjusted by using technologies, for example in adsorption processes or cryogenic distillation. The fuel is frozen close to absolute zero into pellets to be re-injected into the plasma.
The second key area is breeder extraction and purification, which extracts tritium that is bred using breeder blankets surrounding the plasma. The blankets capture neutrons released by the fusion process to convert lithium into tritium, as well as generate power. The key function of this area is to extract more tritium from the blanket than the associated fusion plasma consumes, enabling the plant to be tritium self-sufficient. Various types of solid and liquid breeders are being considered by the fusion industry, which employ different methods for tritium extraction. Extracted tritium and other species are either sent to the fuel recirculation area of the fuel cycle or tritium recovery.
The third key area is the tritium recovery system. Its function is to protect people and the planet by almost complete recovery of tritium. This system uses a variety of technologies to recover trace tritium from different streams, including low-concentration tritium streams from fuel recirculation, coolants used to cool the breeder blankets and in-vessel components, and secondary containment purge streams. Conversion to water has been shown as an effective way to capture trace tritium from streams around the fusion plant. Following this, the water is captured and processed into hydrogen isotopes and oxygen. The hydrogen isotopes are further processed by cryogenic distillation, with the tritium and deuterium recycled as fuel.
Import and export is the fourth key area, which manages the tritium and other process gases going in and out of the fuel cycle. An initial supply of tritium will be imported before tritium self-sufficiency is achieved with enough breeding. Tritium is stored on adsorption beds where it can be controllably recovered by heating and sent back to the fuel recirculation system for reuse as fuel. In all areas of the fuel cycle, there is a need to account for where and how much tritium there is. A range of different analytical techniques combined with a sophisticated control and reporting system will be used for this. Moreover, tritium is a very small atom, which means it can permeate through materials. Where appropriate, additional layers of containment, permeation barriers, or additional tritium recovery processes are used to manage tritium permeation.
A fuel cycle is an essential function for the safe and efficient operation of all fusion plants. The understanding of and integration between its complex systems, as well as with the rest of the plant, will enable the future commercialization of fusion power plants.